Okay, so sorry I'm not here today. I my son is sick. He broke his leg, so we've just been kind of dealing with that. So what I've done for today for you guys to do is you're either watching this with the sub. It might be easier just for you guys to watch it on your devices, connect to the Wi-Fi. But if that breaks down, the sub will have it playing. So we're going to try and go through this like a class. And you can fast forward, pause, and this will be on haiku. So if you need any other questions, you can go ahead and look. But basically, I want you to start this problem. Try and do it without a calculator. If you're on your own, pause it. If the sub wants to pause, you guys try and figure it out. But we're going to get into some review and then some basics with double angles. So this is section 10.3. If you have questions after the video, we'll take time in class to go over that, and we'll talk on Monday regarding quizzes and going over that stuff. So we're kind of pausing right now as far as the class is concerned because life sometimes takes over. So first thing we're going to do though is I want you to try and solve this equation and put it in radians. And so what I would do here is I'd notice the square, and what we want to do is we want to think that it's just like this, but we have a trig function. So if we had this problem, I would just take the square roots of both sides, and I get plus or minus 1 over root 4. Square root of 1 is just 1. And so x is equal to plus or minus 1/2. We're going to go ahead and solve this the same way. And sine squared of an angle is the same as sine of an angle squared. So we can just kind of think of it that way. So I'm going to go ahead and move this stuff up. So when I solve it, you don't have to put it as x, but if that makes sense, you can do that. So I'm going to solve it like a traditional equation. And then I know sine of an angle is equal to plus or minus 1/2. Okay, so now the question, even though it says solve the equation in radians, is what's the angle measurement? So where do we have plus or minus 1/2? So I have to think about where is sine equal to 1/2. And from our chart we know 30, which is pi over 6, is equal to root 3 over 2 and 1/2. So those are my, going to be where I get my solutions from. Then I also need to think about where it's positive and negative, because my solution has a plus or minus, or my trig value has a plus or minus. So I need to locate all of these guys. So for some of you, you might need to think, okay, it's quadrant 1, which is 30 degrees, quadrant 2, which is going to be 150, right? 180 less 30, because this is our reference angle. Quadrant 3, because that would be negative, is 180 plus our reference angle. And quadrant 4, also negative, is going to be 360 minus our angle. So we need to take all of these and convert them to radians. Well, 150 is just 130 degree angle less than pi, right? We talked about this at the beginning of the class with review, and we kind of thought to ourselves, okay, well, how many 30s are in 15? Well, there's 5, and let me highlight this. There is, how many times does 3 go into 15? And so 130 degree measure is pi over 6, so 5 of them go into 15. I'm going to have 5 pi over 6. Same rationale is if I have, how many times does 3 go into 21? That would be 7. So that's going to equal 7 pi over 6. I'm running out of room here on my screen, so I'm going to move this up. And, using that same logic, I'm going to say 3 goes into 33 how many times? And that is going to be 11 pi over 6. So these are all of my solutions. Okay, so I'm going to go ahead and go to the next slide. This is actually what my son is dealing with a little bit. If you notice here, this is a picture of his x-ray, and this is his femur. And so the femur is, I'm not a doctor at all, but the femur is basically, from your knee to your hip, right? And this is about the middle of his femur, and you can see that we got a break right here and a break right here. This is what they call displacement. If one of us was to do this to our femur, we would have to have a rod. But what's amazing about the human body, because he's so young, they'll actually just pretty much cast it up, put on a brace. He's immobilized for a couple weeks, and it'll actually grow back together without any issues. Thankfully, no surgery is required. But you can see here how it is separated. So for those of you who are squeamish, just pass through that. I probably should have put a warning, but it is what it is. So that's what we're dealing with at home right now. So once we get back into the swing of things, we'll take class and progress where we need to progress with, and if we have to take our time because I'm out or whatever, don't worry about that. That's going to be okay. So now we're going to start with double angle formulas. And we're going to start to derive these double angle formulas, and then I'll have I'll chunk them so you're not watching a 5-minute video or 25-minute video. So what we're going to do is we're going to come up with some formulas, and rather than doing a discovery, actually pause the video and try and figure it out, because I think it's important that you know where they're derived from. But basically, with the double angle, what I'm going to look at is how, if I have a double angle, 2 times 30 is doubling the angle. That's equal to 30 degrees plus 30 degrees, right? So the way that I work this is I go ahead and I say, okay, well, if I have 2 angles that are the same, that means alpha is equal to beta. So then that means I can do sine of alpha, and instead of adding a beta, I would add an alpha, right? Because they're the same, okay? And so this is our angle addition formula, so I'm just going to expand that. And look what I got. It's multiplication, so order doesn't matter, so I can switch these guys around. So I really have sine of alpha, cosine of alpha, plus sine of alpha, cosine of alpha. And we'd work with like terms, so we know we have 2 of these. So it's just like if I had apple plus apple, it would be 2 apple. So this is 2 sine alpha, cosine alpha. And that is actually our sine double angle formula. Okay, you may have to come up with that on a quiz or a test. So I'm going to go ahead and I'm going to stop the video here. What I'd like for you guys to do is try and apply this to the cosine formula. I'll have a separate video that shows that process. Okay?